So I've been playing around today mostly because there's no open source projects out there that show how you can use machine learning and Selenium together. So I started trying to hack something together for a demo, really. So I'm going to run some Selenium code first of all. And in this first step, all it's going to do is fire up the amazon.co.uk webpage. And first of all, it's going to take a screenshot of the full screen. And then it's going to look for anything clickable. So it's using an XPath looking for input areas and hyperlinks. And what it's going to do, it's going to record all of the XY coordinates of all those different coordinates and controls in the screen. And then it's going to also output a snapshot just of that particular control in PNG format. Okay, so it's found a couple of hundred different things on the Amazon page that we can click on. So there's quite a lot there. So as you can imagine, for an automated test, it's going to be quite hard to determine which of these is a specific item. So I'm actually, first of all, going to kick off the machine learning process based on those outputs. And then I'm going to show you the code. Okay, so as I said before, I'm snapping out anything that matches a couple of different XPaths. So hyperlinks and input fields. And what I'm trying to do here is I want to determine how to press this search button, the magnifying glass at the top here. Now, why would I use machine learning? Well, that location may change on the page, but it's unlikely that it won't be a magnifying glass at the end. So I'm using kind of usability constructs and iconography to navigate around rather than screen locations or anything to do with the code itself. So just to show you my code, the first thing I ran was pulling up WebDriver, maximizing the screen, taking a screenshot, and then finding anything that matches these XPaths, and then taking an image of that particular element in the screen. So I'm basically cropping the full screen image down to the XY coordinates I've got from Selenium. Once done, I run this code. This code is just firing up a TensorFlow model, which is looking for a magnifying glass. Now, this is all based on an open source project, but I had to hack it around a bit in order to get it working. The credit where credit's due, this guy is the guy who got the initial code up and running, a guy called Ranjan, and you can find his GitHub page here. Now, if I pull up the actual processing the model's doing, you'll see that it's running through each of those images, and what it's doing is coming up with a probability that that is a magnifying glass. Now, if I just show you all the images, first of all, that it's processing, that might make a bit more sense. So here you go. So it's pulled all the clickable links off Amazon. So as you can imagine, it's found loads of stuff just on Amazon's homepage. 316 separate images, which range from things that would make sense to things that don't make a lot of sense, even to a human. So as the process is running here, it's identifying those probabilities, and the one we're looking for is actually image 7. So that looks like this. Okay, so it matches the Amazon homepage. And what we're finding on image 7 is an 86% probability that is a magnifying glass. This is a number too small to show, but it looks like a big number using this notation. Same with this one. So number 50 at 42% is the next most likely. Let's take a look at image 50, see if it makes any sense to us. It doesn't. It's accept cookies and customize cookies. I guess that shows you the imperfection of machine learning. So this is now going to go on for some time, and the hopeful result is that image 7 has the highest number. So the code I haven't written yet is to then feed that back into Selenium and get it to click on that magnifying glass based on the probability. But I'm sure you can imagine where this is going.